Observability vendors like to charge you by the gigabyte. What happens if we set up an observability system that just holds 15 terabytes of data at fixed cost? In today's episode, we'll set up an AWS CloudFront analytics powerhouse. Our budget, $275 a month. Hold my whiskey. Hi, I'm Jack Neely, and I'm the owner of Cardinality Cloud, LLC, where observability is leverage, not a tax. I have 25 years of experience doing DevOps and SRE work, over a decade of that as an observability subject matter expert. Today, let's see how we can avoid the gigabyte trap. In my crawl, walk, run framework, this is the first video around walk with logs and observability. We've got more than a terabyte of logs coming in per month. We're starting to ask questions about we need a real system to analyze these logs. We're looking at performance and holistic questions, usage patterns, perhaps SLOs. How do we start getting real use out of that real data that we've been collecting? So our goal for this episode is to set up monitoring around latency percentiles for our websites. We're going to use AWS CloudFront logging data, and if we can get graphs for percentile information on our latency, that's what we're going for. We're going to measure the costs that we spend on this. Is this achievable by any mere mortal? I think so. I think anyone kind of at the walk stage of their observability journey should know enough about putting together a system that looks similar to this. Is this relevant to your job? Measuring the performance of your website, your web apps, your latency and percentiles? You bet it is. How long does this take to do? I did this in a day while having the flu. You can do it too. Some caveats. This isn't generic logging. This isn't monitoring for uptime. This is being able to ask more holistic questions about your websites and how they perform and how your customer relates to that. The architecture I'm going to set up is, relatively simple. We're obviously using AWS CloudFront. Now, CloudFront is a global service. It runs in many different regions, but it can shove logs into one specific regional AWS bucket. So we're going to enable CloudWatch to store its logs in S3. And I'm going to use ClickHouse to read those logs out of S3 into a ClickHouse database. And from there, we can use any number of visualization tools to make sense of the chaos. So let's look at our budget pretty carefully. We're going to use a ClickHouse Cloud instance. This is the largest consumer of our budget. It's going to cost about $220 a month, one 8 gig instance. ClickHouse is going to use the S3 table engine to extract data from S3. That's using S3 APIs rather than network bandwidth. But at 30-second pull intervals, that's less than 50 cents. We have storage in our S3 at 2.3 cents per gig a month. And storage in ClickHouse is also really cheap at 2.5 cents per gig a month. Storage in ClickHouse is also in S3, so the pricing's super similar. So what we want to do is avoid network ingress and egress costs, including data transfer out or NAT gateway costs in AWS land. And we're doing this by locating our S3 bucket and our ClickHouse Cloud instance in the same AWS region, and we're using S3 APIs to access that S3 bucket rather than transfer the data. So CloudFront writes the data into S3. That writing is free. We pay for storage. ClickHouse reads the data from the S3 bucket. Reading data is free. We pay for the API call. This leaves us with a little bit of cost left over for storage. I'm estimating about 2 terabytes, which costs similar in both S3 and ClickHouse, and 2 terabytes compressed. ClickHouse charges based on the amount of compressed data we store. So that equals 14, 15 terabytes of data. That's 5 terabytes a month to have 90 days of data. That's a reasonable log-based observability system. So how do we build this? Step 1, use Terraform, OpenTofu, what have you for your infrastructure as code. Set up your CloudFront distributions like you normally would. Make sure to enable logging and point that at an S3 bucket. And know where that region of that S3 bucket is. It's easy to have multiple CloudFront distributions. I use prefixes in my S3 bucket so that all of my CloudFront distributions stream logs to a specific prefix, so it's easy for me to inspect in the bucket, are my logs working? Next is setting up the AWS IAM role, and I'm a professional at this, and this took me the most time. But what we have is ClickHouse Cloud instance running in a foreign AWS account, and we have our local AWS account where our S3 bucket is. So if you look at your ClickHouse Cloud instance in the console and look at network security settings, it will give you the ARN of the AWS IAM role that ClickHouse Cloud instance is running under in that foreign account. Copy that. We need that. In our local account, we need to create a new IAM role. I named it something starting with ClickHouse. I set up the trust policy for this IAM role so that the foreign account IAM role could assume this new role in my account. And I gave this new role in my account access to read the S3 bucket. Next, we have the ClickHouse Cloud schema. And surprisingly, this was really easy to create. I told AI that I wanted to do this project. It found the schema for CloudFront logs, how they would appear in AWS as gzip files. It built the entire schema, and it really took something that would have taken me hours or days and just dumped it out in minutes. So the S3 queue concept that we're using from ClickHouse has 3 different parts to it. There is a queue table that reads in data from S3. There's a destination table which contains all of the data in my post-processed format. It's the table I'm going to query stuff out of. It's the table that's going to grow. There's also a third layer, which is a materialized view, which triggers the queue, transforms that data in any number of ways, and inserts it into my destination table. So I will include in the description below a link to the schema I used. Roast me in the comments. One thing the AI did was it added a bunch of float32 data types. Thanks, AI. So did I have to go through this schema and read it and correct it, and then AI profusely apologize for using float32 and fix them all with float64? You bet. So definitely watch the schema that AI is generating for you. It can definitely speed you along, but pick up enough SQL so you can kind of tell the difference where it may be going astray. And I'll save my rants about IEEE 754 for a different video. The next step is really just doing some debugging. And here on the screen is the SQL statement that I use just to select the files and number of files that I see in my S3 bucket to make sure that I've got my IAM account and IAM authentication working, as well as the file glob that I'm pointing ClickHouse at. I ended up having multiple problems as I was debugging the situation. The first one being my IAM role didn't work, and the second one being my glob pattern was wrong, which at one point gave me errors that all looked the same. So this is what I use to be able to figure out, am I getting data or am I getting access denied errors? Once that's set up, you should be able to do a query on the destination table and start seeing data. So now that the data's in our destination table, let's look at what we can do. Here's the SQL that exemplifies the goal of this video. It queries all of the website hits for today. It does percentiles for each website code, 200, 302, 500s, and it's able to show me that over time. So this SQL shows I'm able to accomplish the goals that I wanted to out of my observability system that we set forth. We can also do simple CLI bar charts in ClickHouse. Again, this is more or less for debugging, but we can definitely use this to show if the data is working as we expect. The ClickHouse Cloud Console also offers a dashboard feature. We can create some SQL queries and dashboards around those, and we can also see percentile measurements over time of how our website traffic is working. This isn't really an observability dashboard, but if you know what time ranges that you want to look at, it works. It works really well. I've always been a big fan of GNUPlot. It's really where I cut my teeth doing analytical work at a research university right after I graduated. This is what scientists and engineers used to write papers and prove points for many decades. So GNUPlot's a really powerful tool. And in fact, we can use ClickHouse and dump out tab-separated data, pipe it directly into GNUPlot, and there we have our graph. So, of course, the golden standard for observability is, can you get it working in Grafana? So head over to grafana.net, create a free instance. Their free forever tier is pretty generous. Once that's set up, go into Grafana, add a ClickHouse data source, point that at your ClickHouse Cloud instance that you've set up, and it will praise you for connecting your data sources until you're ready to go. With a simple question to AI, I was able to take my existing SQL and transform it into the exact flavor that Grafana wants to be able to insert custom and specific time ranges. So it works with a time picker. And here's the same graph again. And in fact, AI was able to produce a really comprehensive dashboard in Grafana for my CloudFront logs, including geolocation, including percentile-based latencies, and really pretty much everything else I could have wanted. So let's look at a couple trade-offs that we have with this setup. First is, well, latency. The S3 queue method of pulling in data from an S3 bucket in ClickHouse introduces latency. Now we can configure this, and I configured it for 30 seconds as the highest interval. The polling interval is adaptive, so it does shrink and compress accordingly to how much data is coming in. But again, this isn't exactly real time. However, AWS CloudFront logs aren't real time either. AWS promises to deliver logs at least once an hour and within 24 hours at worst. Now, granted, it's collecting logs from worldwide inputs and shuffling them into one regional S3 bucket, so yeah, it's not going to be exactly real time. But this solution is good enough to be able to do a lot of analytics on the website, judging health, starting to look at those core web vitals. So it actually works quite well. The second real trade-off here in this particular demo is S3 storage. I'm storing the data twice. Fortunately, storing data is relatively cheap. If this were an enterprise setup, what I would probably do is use S3 for long-term archival storage and just use ClickHouse for hot storage for 60, 90-day range. And if I need to keep data for enterprise requirements or compliancy issues, I would go back to my S3 bucket. Or I could simply use my S3 bucket and keep data for a couple weeks and just use it as a staging area. So there you have it. Production grade dashboards for AWS CloudFront base distributions, graphs and Grafana, full control, you own all the data. $3,300 per year. Not per month, per year. Can your vendor do that? If you want help building something like this for your team, or you want to get in front of your CFO coming at you with a six-figure observability bill, that's what I do. Link in the description.